Hello there, students. So in your notebooks, you should take those out, and at the top you can just write law of cosines. But these are our notes that we're going to take before our next class. So law of cosines, we're going to talk about today. And remember how we've been talking about triangles. We've been talking about specifically about triangles that are non-right triangles. So law of cosines will also be similar. We're going to draw a triangle. That's non-right. So sketch a triangle on your paper there. That's a non-right triangle. And we want to label our angles and our sides. So just like how we labeled our law of sines, we're going to label this. We'll say that this is C. We'll say that this angle is B. We'll say that this angle is A. And we're going to label our angles with capital letters. And then the sides opposite of them, to make it easier, we're going to label with the lowercase letter of that letter. So we have capital A here. The side opposite of it is going to be labeled little a. The side opposite of B will be a little b. And then the side opposite of C, or angle C, we're going to label with a little c. So make sure you kind of exaggerate that little c so that it's definitely smaller than your angle. Because we're going to use, instead of talking about segment AB, we'll also just refer to it as little c, as being opposite of angle C. Now, law of cosines. Well, cosine, we know it has to do with right triangles. So let's draw a height on this triangle here. So wherever A is, we're going to add in a height. We'll just call it H. So our height there, now we have two right triangles within our non-right triangle of ABC. So we have an H here. And then cosine, cosine also has to do with SOHCAHTOA. So cosine is the ratio of adjacent over hypotenuse. So let's remember that. And we're going to talk about this side down here. Let's label this side. We'll call this first part right here, we'll call it M. And then, so M is the distance from here to that height that we drew. And then if the whole thing is A, then we can call this other side, so this part right here, we can call that A minus M. So A minus M is from right here to angle B, and M is from here to the height. And really, these are both just talking about this side A and different parts of side A, but we want to break it up to help us figure out our law of cosines. So we're proving this in order to be able to use it in our next class. So first, let's just think about cosine. So if we find the cosine, and we're going to do this in terms of angle C. So the cosine of C, we know, is adjacent over hypotenuse. So adjacent would be M, and our hypotenuse there would be B. Now, all of the letters that are in blue, so on the inside here, we'll eventually want to get rid of them. So let's just solve for those, okay? So here, let's solve for M, and we're going to multiply both sides by B then. So we'll get M equals B times cosine of C. And we'll use that as a little later, okay? Another thing we can do is we can look at these triangles, and something we know how to use with right triangles is, in looking for sides and angles, is we can look for the Pythagorean theorem. We can use the Pythagorean theorem. So let's try. So our next part, we're going to look at this triangle right here. Okay, we're going to look at that triangle and do the Pythagorean theorem. So we would write a minus m squared plus h squared equals c squared. So looking at this triangle, we know that the Pythagorean theorem would be a minus m squared, h squared equals our hypotenuse squared. Okay? And remember, eventually we want to get rid of all these letters that are in blue, so let's just solve this for h squared. So we can say h squared equals c squared minus a minus m squared. Okay? So we know that on the triangle on the left side, we could also do the Pythagorean theorem. So on the left side here, we could write, I'm just going to create a little more space here and move these over a little bit. We can also write that m squared plus h squared equals our b squared. Now, this one, remember we want to get rid of things, so I'm going to solve this for h squared also. So I have h squared equals b squared minus m squared. Now here, notice how both of these sides are equal to h squared. So if they're both equal to h squared, then I can set these equal to one another. So I'm going to do that, and I can set up that. So I could say, this first h squared, I could say c squared minus a minus m squared equals b squared minus m squared. Okay? So I just set those two h squareds, whatever they were equal to, I set those equal to one another. Now, I'm going to do just a little bit of algebra. So I want to move this part, this minus the a minus m squared, I want to move that to the other side, because eventually I want to try to get rid of this m squared. So I would have c squared equals b squared minus m squared plus a minus m squared. And make sure you put that in parentheses. Now, we're going to just manipulate this a little bit more. So we're just using algebra. Let's think back what we did. We just substituted here, and then I added this part to the other side, and that's how I got it over here. Now, this a minus m squared, we want to FOIL that. So some of you may be able to do that in your head, some of you may not, but I'm going to write this part in red, so you're welcome to write it with me, or you don't have to. So, oh, that's not red. Alright, so over here, if we FOIL that part out, we really, when we square it, remember that that means that we have a minus m times a minus m. So we're going to distribute this out. So a times a, we get a squared minus am minus, and then ma, and I could switch those around, so I can also say minus am, because alphabetical usually is seems to be a better way to go. And then I can distribute the last two, and I get a negative times a negative is a positive m squared. So now I can combine my like terms, and I'll get a squared minus, and notice how I have am twice, so I have 2am plus m squared. So now when we write this, we're going to substitute that in for a minus m squared, because we know that they're equivalent. Okay? So I'm just going to move this so that we can still see it to use. So this part you could have done in your head, but we'll use that now in order to rewrite this. So at the beginning, we had everything in terms of A, B's, and C's, and then we added all these in. So we're trying to now get rid of the M's, the H's, and just have A, B's, and C's in there. So let's see what we have now. We can write this as C squared equals B squared minus M squared plus, and now I'm going to write what I FOILed this to. So I get plus A squared minus 2AM plus M squared. Now, what do I notice here when I combine like terms? Notice that there's a negative M squared and there's a positive M squared. So those M squareds can actually cancel out. And then I usually like things written alphabetically, right? So I'm going to start this off and say C squared equals, and I'm going to just put the A squared first, because it was positive, so it stays positive, plus B squared, and then minus 2AM. So notice at the beginning here, it looks like the Pythagorean theorem, but it's not the Pythagorean theorem because we know that doesn't work unless it's a right triangle. So we have to add this other part, or really subtract this other part. Now let's go back. We want to get rid of all of the letters besides A, B's, and C's. So do we know what M equals? Well, look up here. Remember before we solved it on our paper, we saw M equals B times cosine of big C. So we can replace that also. And we get C squared equals A squared plus B squared minus 2A. And then in place of M, we're going to write what we had right up here. So we're going to write B times the cosine of big C. And now we have gotten rid of all of the M's, the H's, and now we're only left with little c, little a, little b, another little a and a little b, and then a big C. So therefore, if we're given any triangle, and we know something about the sides or about an angle, we can solve for the rest of it using this law. So let's put a box around this. This is the law of cosines. Now, another way to write this is sometimes we might have to solve for an angle. So we're going to just solve this so that it's written in a little different way. So how we do that is what I could do C squared. I can take away my A squared, and I could take away my B squared. And that'll equal negative 2AB times cosine of C. But what else I want to do is I want to get rid of this part that's out in front here. So I can divide both sides by negative 2AB. So I can have C squared minus A squared minus B squared divided by negative 2AB equals cosine of C. Now, that's one way to write it. Another way to write it that you might also see is, what if instead of minusing our A squared and our B squared, what if we added, so that we got a positive here, what if we added this to the other side? So another option is we could do C squared plus 2AB cosine of C equals A squared plus B squared. Now we'll probably see this one more often. So now if we want to get rid of this, we can minus our C squared. So we'll have 2AB cosine of big C equals A squared plus B squared minus C squared. And now let's divide. So we would get cosine of C equals A squared plus B squared minus C squared all over 2AB. Now all of these in the boxes here, all of these are equivalent to one another. They're all allowing us to solve for different things. This one would look more for an angle, this one would look more for a side. And as we continue practicing this, you will need to have memorized this one for sure. And another one to help would be this one. This one below is equivalent. It's the same thing, but this one is more positive numbers, so that's usually easier for us to understand. So in our next class, we will talk more about applying this to problems. But now that we've seen our proof of just using algebra, using the Pythagorean theorem, using SOHCAHTOA, then we can actually apply the law of cosines to different questions. So I will see you at our next class. See you then.